Hello Year 12 and welcome to our third exercise here for networks. We're looking at maps and networks today. Really, I should probably call this graphs and tables because that's what we're going to be looking at. Because we have mostly until now looked at our networks as a graph, like as dots and edges. Yeah, vertices and edges. Right, we've drawn them up. But we can also represent this using a table with rows and columns, and the vertices are going to be labelled in the rows and the columns, and I suppose that's because every edge has two ends, right? So one end will be the row, and the other end will be the column. So here we go. Here is a table: ABCD, ABCD, and I have some numbers in there because this is going to be a weighted network. I've grayed a lot of them out because this is not, because we typically, up until now anyway, and for now, A to B is the same as B to A, right? So my table is sort of repeating lots of things there, and I've also grayed out the A to A, right? So this cell here represents an edge that goes from A to B. It's 5 units long. There is an edge from A to C that's 2 units long. If I come across here, B and C, right, I've just got a little dash there. So that's suggesting there isn't an edge between B and C. This shows me there are 4 edges in total. So I start by drawing up 4 vertices, okay, because I've got A, B, C, D. So there's 4 vertices. I've laid them out like this. You can lay them out any way you like. You might get a graph that looks slightly different, but it will mean the same thing. So there's my 4 vertices, and then I put the edges in. So the edge from A to B, here we go, A to B is 5 units long. From A to C is 2 units long. From A to D is 3 units long, and then from B to D is 4 units long. And that's all the edges there are. You can see here there's no edge between B and C, so there's a dash there. There's no edge between C and D, so there's a dash there. So here's an example. This time I have 5 vertices, and we're asked to represent this table as a graph. So I start with my 5 vertices. I've laid them out here sort of equally spaced apart. That's a good approach typically. And then I will label them A, B, C, D, E. It'll get pretty messy, pretty confusing if you don't do that. Then we have a look. I'm going to go down the A column. So nothing from A to A to B, there is an edge, right? And I've labelled that with a 1. Next up, from A to C, there is an edge, and I've labelled that one as well. There's nothing from A to D. The next one is from A to E, so I draw that in and label it with a 3. Right, so those are all the edges coming out of A. Right, you can see 3 edges in the A column, and there's my 3 edges there. Now, we'll work down the B column. Nothing from B to B. B to C is a 2, B to D is a 4, and B to E is a 10. Okay, we're starting to build this up now. Now the C column. Now you see I don't have to do C to A because I've already done A to C. Same with A to B. So C to D is 5, C to E is 8. Right, only a couple left now. D to E is 4. Now I've got a 7 here in the E to E. This is a special case that we haven't spoken about before. So where I have an edge that is connected to the same vertex on each end, we call that a loop, and we just draw a little circle there like this. Okay, so I have a loop of length 7 at E, so that can occur. There we go. So that is a graph, a network graph, that corresponds to a network table. Right here. Here's another example. This time I have a graph and I'm asked to represent that with a table. Again, I have 5 vertices, so I start by drawing up a table with 5 rows and 5 columns. In fact, Mine's 6 by 6 so that I've got space for my labels. So there's my 5 columns labelled A, B, C, D, E. Right, a column for every vertex and a row for every vertex as well. Now we'll start examining our graph so that we can put the figures in. So having a look here, there is no loop at A, so I can put a dash in the AA. There is an edge from A to B, and it's 2 units long, so I put a 2 in that cell there. Right. Still having a look here, from A to C, there is an edge, and it's 1 unit long. There's no edge between A and D, so there's a dash. There's no edge between A and E, so there's a dash. I've also just sort of jumped in here now and shaded out those repeated cells, because this cell here represents B to A, and we've already looked at A to B, and for the time being they mean the same thing. So I don't need to put those in twice. I've grayed them out. There's no loop at B, so I'll put a dash in there. But from B to C there's an edge that's 4. From B to D, right, B to D there's a 2. B to E is a 6. Right, and I keep working my way along. No loop at C. CD is 9. CE is 3. D, no loop, there's a dash. DE is a 7. And no loop at E. So that's it. Finished. We've created a table there. That represents this network graph. If we want to do a bit of a check here, I can see this shows me that I have 8, count them up, 1, 2, 3, 4, 5, 6, 7, 8 edges. And if I carefully count all of the edges here, we find there are 8 edges as well. It is a little tricky counting those edges, but I'll show you a bit of a tip. We can count the degree of a vertex fairly easily. Right? We won't miss anything if we look at one vertex at a time. So A has a degree of 2, B has a degree of 4, C has a degree of 4, right? Because there's 4 edges coming out of there. D has a degree of 3, and E has a degree of 3. Add those up, 2 and 4, plus 4 is 10, plus 3 is 13, and another 3 is 16. So if I add up the degree of every vertex, I get 16. But because every edge is connected to 2 vertices, the number of edges is half that number, is 8. So you can find how many edges are in a network, even if it's complicated and they overlap and whatever else. I can count up the degree, or add up the degree of every vertex, and divide that by 2 will tell me the total degree of the network, or the number of edges in that network. Rightio. Well, that's it for this exercise, for this video. Just to recap what we talked about, networks can be represented as a table as well as a graph, right, with a row and a column for every vertex. And just this other little bit of information that we picked up along the way, a loop is an edge that's connected to the same vertex at each end. Rightio. That's it. If you've got any questions arising from this, please ask me during class or send me a message and I'll get back to you as soon as I can. Our next exercise will be on directed graphs. Okay, thanks very much, Year 12. See you in class.